The next topic in Unit 2 is regression line prediction and residuals. We are going to continue working with scatter plots in order to create a regression line that allows you to make predictions about unknown values. So a regression line summarizes the relationship between two variables, but only in a specific setting, when one variable helps explain the other. So the regression line must have an explanatory and a response variable. So an example of this is a line that describes how a response variable y changes as an explanatory variable x changes. This formula right here should look familiar. It should look similar to your slope-intercept form, y equals mx plus b. Remember that we're only working with linear forms when we're creating regression lines. So the only difference here is your b and your mx are actually switched. Your b is here, and then b1 times x would be your mx. So this would be y equals b plus mx if you were to switch those two around. So we are talking about slope-intercept form when talking about regression line predictions. Y hat, so when you have a y with a hat on top of it, is your predicted value of y for a value of x. So whenever you see this symbol right here, you know they're talking about a prediction, not a true value. So an example of this might be that you might see a correlation between the amount of time you study and your test score. The more you study would be your explanatory variable, your response variable would be your test score. So if we look through some examples, they can give you the regression line and ask you to interpret it or find values based on the regression line. So hopefully on your copy this red line came out. I know the copier doesn't always copy color very well, but the question is, what is your best guess for university GPA for a student with a high school GPA of 2.5? So high school GPA is going to be my explanatory variable, and university GPA is going to be my response variable. Explanatory is on the x-axis, and the way I remember that is there is an x in explanatory. So this x tells you that it's going to be on the x-axis, and then your response variable is going to be on your y-axis. So they want us to find high school GPA of 2.5, which is right here. And I'm going to trace that up to my regression line. So when my high school GPA is 2.5, my university GPA is approximately 2.75. So between 2.5 and 3. I know that's a little bit hard to read, but between 2.5 and 3, you would have a university GPA of 2.75. Second one is very similar. It says, what is your best guess for a rating for a piece of candy with 3 grams of sugar? So the grams of sugar is going to be your explanatory variable, and the rating is going to be your response variable. 3 grams of sugar would be approximately right here. So we're going to go up about right here, over. So somewhere between 45 and 55, looks closer to 55. We'll say 52 would be the rating. Doesn't give us a unit for rating, so we're just going to say 52. So again, your explanatory variable can predict your response variable when you're given a linear regression line. On the next page, we go through how to calculate the linear regression line using your calculator. So example number 1 says cars and trucks lose value the more they are driven. Can we predict the price of a used Ford F-150 truck if we know how many miles it has on the odometer? A random sample of 16 trucks listed on autotrader.com are summarized below. So this table is a little bit difficult to read. So the miles driven are here and here, and those are going to be your explanatory variables. And the price is going to be your response variable. So when you type this into your calculator, you're going to type all of the miles driven, so all 16 of these in L1, and then all of your y's or all of your response variables in L2. Alright, so we're going to go ahead and do that. So to type this information in your calculator, stat, edit, clear out your list, and again, explanatory in L1, response in L2, and it does matter that you do put these in the right order, so explanatory in L1, response in L2, or else your regression line will not be calculated correctly. So for explanatory, I'm typing all of my miles driven. So 7,583, 129, 484. Okay, so that is all 16 values for miles driven, and now I'm going to do all 16 values for price. It's also important that you put these in order because the correlation between these two values is going to help you and is what's going to be able to give you your linear regression. So make sure you type these out in order and then these out in order. Everything has to be in order for this to work correctly. Okay, finally done. Alright, so once you should have the equal amount of numbers in L1 and L2, 16 in each, and now you can calculate the linear regression line. So to do this, you're going to go stat, go over to calculate, and we're actually going to use number 8. So on your paper, it says to use option number 4. I want you to change that to option number 8. So we're always going to use option number 8. It looks very similar, but it has the A plus BX, which is how it is going to be on the AP exam. So your output is y equals A plus BX, and they give you A and they give you B. So for my linear regression line, I'm trying to do this so you guys can see the best. I would have y equals A, which is 38,257.14 minus 0.163x. I just rounded to 3 decimal places. I rounded to, really you should round to 2 because we're talking about money. So that's why I rounded to 2 decimal places here, because those would be your cents. So if you rounded to 2 decimal places here, it would be 0.16x. So again, I got those numbers. It gives you your A value right here. It gives you your B value right here, and you just plug those in for the A and B in the linear regression model. You should be recalling that R value from the last packet. That R value is going to be your correlation, and if you look at this, you see an R value of negative 0.8. In your mind, you should be thinking that's negative and that's strong. That's a strong negative correlation. So part B asks you, what is the predicted price of a used Ford F-150 truck with 100,000 miles? Well, in order to do this, you need to be thinking about what Y represents in the context of this problem and what X represents in the context of this problem. And we already talked about that a little bit up here. So we said our X, or our explanatory variable, is the miles driven. So I'm going to label that up here. And it's a good habit to get into labeling your variables, because when they ask you questions, you'll be able to quickly plug those numbers in or substitute those numbers in for the right variable. And Y is going to be my price in dollars. Okay, so they asked me the price for a truck with 100,000 miles. Because I've labeled my variables, I know I just need to plug 100,000 in for X. So Y equals 38,257.14 minus 0.163 times 100,000. And I'm going to type that straight into my calculator. So I have 38,257.14 minus 0.163 times 100,000, and I get $22,227.14. So a Ford F-150 truck that has 100,000 miles on it would be worth $22,227.14 according to Autotrader.com. We can do another prediction. It says, what is the predicted price of a used Ford F-150 truck with 300,000 miles? So I'm going to do the same exact thing, except this time I'm going to use 300,000 miles instead of 100,000 miles. So y equals y hat, definitely y hat. So your predicted value, so you should have that hat over y. That does make a difference because we don't know for sure that that's the exact price. Your truck could have damage on it. It could have gone to an accident. So it's the predicted price based on these values. So that hat tells you it's a prediction, not for sure. So 38,257.14 minus 0.163. Same exact thing, but this time we're using 300,000. And I get negative $10,372.86, which tells me that they would have to pay you to take this truck with $300,000. So the predicted price would be negative, so that would probably never actually happen. So because it's negative, you know that that wouldn't happen. In the next video, we will talk about extrapolation and residuals, so I will see you in that video.